Okay, next example is if we have divide by the x is equal to x plus 1 divided by x squared plus 5x plus 6. From this equation, you would see that for the denominator, the power of the denominator is less than the power of the denominator. So that means we probably be able to use the partial fraction technique to find the solution of this differential equation. But the next thing that we got to concern is about the denominator terms that can be separated into two terms. Can we? X plus 2 and x plus 3. So in that case, if you take a look at the roots of x, you have negative 2 and negative 3. So which is a real number and unrepeated. So we can use the partial fraction technique to find the solution. Now I want you to use the formula that I give you to find the value of A1 and A2 of this problem. I want you to try it by your own in order to know that you know how to use the formula. And tell me what is A1. What is the value of A1? What is the value of A1? Plus 1 or minus 1? Plus 1 or minus 1? What is the value of A1? A1, how do you find? You said limit of x go to what? Minus 2, right? And then up here you got to put what? X plus 2 times p. P is mean this one, right? This one and this one, you take it out, right? Now you plug x equal to minus 2 in there. Minus 2 plus 1 equal to minus 1. Minus 2 plus 3 equal to 1. So A1 is equal to minus 1. Now what is the value of A2? You find A2, you said limit x go to minus 3, right? X goes to minus 3, right? And up here, it's got to be x plus what? Plus, to find A2, whatever under A2, you put it up here. X plus 3 times p, which is your function. You see here, x plus 3 and x plus 3. So you have only x plus 1 divided by x plus 2. So you put x equal to minus 3 there. Minus 3 plus 1 equal to minus 2. And then minus 3 plus 2 equal to minus 1. So you would get 2. Now let's just go to the easiest part. Y is equal to integral minus 1 over x plus 2 plus 2 over x plus 3, the whole thing times dx. Use the integral property that it can distribute and resolve, and also the constant can be taken out from the integral sign. But dx is equal to dx plus 2, right? So we put there as a dx plus 2. Also, dx is equal to dx plus 3. Right? Now, integral 1 over u du is equal to ln u. Just that. Next example. But if we have divided by dx is equal to x squared plus 1 divided by x times x minus 1. We do the integral. Now we know for sure that the denominator term it's already being like separate to each other. But the thing is that, can we just use the partial fraction to find the coefficient a1 and a2? Now you get two terms, right? You would get two terms, right? Because down here you get x squared. You got two terms. So you got to find a1 and a2. But can we do it right away with this problem? I would say that no, we can't. Because if you do the power of numerator and denominator, you would see that m and n is equal. So in that case, you can't do partial fraction right away. The numerator. รวมได้อย่างนี้ก็ได้ค่ะก็เขาแยกเป็น2วงเล็บให้เราแล้วมันก็ง่ายกว่าแต่กรณีนี้ but this one we just can't do partial fraction right away because the formula that I gave you is just saying that you can do this when m got to be less than n. But now your m and n is equal. You can't do it. You got to make the one up here smaller number than the one down here. So the way that you do that is just you do divide. Now, you have x squared here, x squared there. What would be the number that you should put up here in order to make them equal? 1, right? 1 times x squared equal to x squared. 1 times minus x equal to minus x. You do subtraction. Up here you got no x term. So you would have 0x minus x equal to plus x. And you have 1 here, put it down. Now your x here have the power of 1, which is less than this one already. So I would say this one, we will write it again, we would get 1 plus x plus 1 divided by x squared minus 1. And then you would get now with the first term you can integrate it already, right? You just distribute dx to 1 here. But for the second term, you can't integrate it yet. But the thing is that now, the power of the one which is on the top is already less than or smaller than the power of the x in the down here term, denominator. So now you can use partial fraction technique to find a1 and a2. Can you find a1 and a2 for me? What is the a1? a1 is limit x go to what? 0. Up here got to be x times px is x plus 1 divided by x times x minus 1. You put 0 here, up here you got 1, down there you got minus 1. So a1 is equal to minus 1. Now for a2 x go to what? X go to what? 1. Got x minus 1 here times x plus 1 divided by x times x minus 1. You plug x equal to 1 there, you got 2 over 1, which is equal to 2. Now, your y is equal to integral dx minus integral 1 over x dx plus integral 2 over x minus 1 dx plus 3. Now, can you do integral of dx? Integral dx equal to x. Integral 1 over x dx equal to ln x. Integral 1 over x minus 1 dx is equal to, like, you got to make dx to be dx minus 1. I'm not doing it because we did it so many times. So you must know. Yeah. So what if the power of x on the top is just a lot greater than the one down here, the one denominator? You got to do dividing until you get x, you get the power of x less than the one at the denominator. Then you can do partial fraction. What if we have divide by dx